Here is a bin packing problem where we want to find the minimum number of 8-foot boards using this list that's provided. So we've got 4 different methods. The first method we talked about in class was the next fit. And kind of the key word that we learned with next fit was try to put the next cut into the current bin. So we've got these 8-footers. And let's start with the first bin, or board in this case. The 2 words are kind of interchangeable here. We've got a 5-footer that we can put in. And then we try to put the 4 in the current bin, but there's not enough room. There's only 3 feet remaining, so we need a new bin. We'll put a 4 in there. Okay. This 1-footer can go in the current bin, so we put it in. And then we've got a 6-footer. It won't fit. So we're going to make a new bin. There's my 6-footer. Okay. We've got a 4-footer, and we want to put it in the current bin, but it won't fit in the current bin, so we need a new bin. So now we're on our 4th one. The 2-footer can fit in there, so we put it in. 3-footer can't fit in the current bin. You might be thinking, but wait, why can't we put it in one of the old bins? That's just not what this algorithm is about. We have to put it in the current one. It's not going to fit, so we open up a new bin. The 3 will fit in there. 2, I can fit the 2 into the current bin. I can fit the 1 in the current bin. But now I've got 6 showing. I've got 2 feet left over. I can't fit that last 3 in the current bin, so I need to open up a new bin, the 6th bin, to get it in there. Okay? So for the next fit, it looks like what we end up with, we need 6 boards or bins. And in the waste, we've got 3, 3, 2, 2, 2, and 5. That's 6, 8, 10, 12, 17 feet of waste. So let's do the next algorithm is the first fit. And we're going to try and put the next cut into the first one that we can fit in, basically, in order. So we've got our 8-footers. And the first cut is a 5. Second cut is a 4, won't fit, so we start a new bin. Now this 1, it would fit in the first bin, so we put it in there. 6 won't fit in the first, won't fit in the second, so we open up a new bin. 4 won't fit in the first bin, but it will fit in the second bin, so that's where we put it. 2, it's going to fit in that first bin, so that's where we put it. 3, well, won't fit, not going to fit, so we open up a new bin. 2, it's going to fit in that third one. That's the first one we could put it in, so it fits in there. And then a 1 would fit on top of the 3, and then another 3 would fit on top of there. So this is a pretty efficient algorithm because we only need 4 boards. And we've only got this waste showing the 1 foot there. So then we've got the next algorithm was, what was it, best fit. Best fit tells us to put it in the next cut in the one with the least amount of space left over. So here we've got our 8-foot cuts again. And we put in the 5. 4 won't fit. So we open up a new bin. Got a 4. 1. We're going to put it in this one because it has the least amount of space. And now I've got a 6 and I don't have any room. So I'm going to open up a third bin. Put a 6 in there. 4. put it in the one with the least amount of space. It won't fit in bin 1, and it won't fit in bin 3, so we can put it in bin number 2. It will fit there. 2, I try to put it in the one with the least amount of space. It looks like there's a tie because both of these have 6, so I don't think it really matters. We're going to pick the one on the left, so it'll fit in there. 3 won't fit, so I start a new bin. 2, put it in the one with the least amount of space. That's bin 3 right there. And then a 1 will go here, and a 3 will go here. Looks an awful lot like the last solution. Pretty much the same result. It might be a different distribution of boards, but it ends up being the same thing where we need 4 boards, and there's 1 foot of waste right here. So then that brings us to our last algorithm that we covered in class, was the worst fit. And in the worst fit, you put the next cut in the bin with the most amount of space left. So here's our 8-foot board. We start with that 5. 4 won't fit, so we look at 4 in a new bin. 1. We've got this 1, it goes in the one with the most amount of space, that's bin 2. We've got a 6, it's not going to fit. We've got a 4, and you put it in the one with the most space available. We don't have enough room, so we need a new bin. 4. 2. It's got to go in the bin with the most amount of space left, and that looks like bin number 4. Now we've got a 3, put it in the bin with the most amount of space left. Looks like we've got a tie. Both of these two have 5, so I can put it in that one. The 2-footer, I'm going to put it in the bin with the most amount of space left. That is this one. 1-footer, you got to put it in the bin with the most amount of space left. So that's going to be bin 3 or bin 4. Seems like it would make more sense to put it in bin 2. We're going to put it in bin 3. And now we've got a 3-footer, and we don't have enough room to put it anywhere, so we need a new bin. So there's our 5th bin. In this case, the worst fit. We're going to need 5 boards. And as far as waste goes, we got 1 here, and 1, and 2, and 5. Looks like we've got 9 feet of waste.